Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is object-oriented programming, and the same chapter, that is chapter number 7. Not the same chapter we have finished in the last class, that is chapter number 6, that is the constructors and destructors. Now I'm going to start with chapter number 7, that is the operator overloading and the type conversions. That is how to convert the different types, that is from one data type to another data type, and how to use the operator overloading. Or what is operator overloading? That is how to use the different operators at the same time. That is how to overload the operator, that is the operator overloading. So let's start with the 7th chapter, that is chapter number 7, operator overloading and the type conversions. Right. So let's start the chapter. This is a chapter that talks about the operator overloading, and it is one of the part of the feature of the C++ language. So the first line says it is one of the exciting feature that is available in the C++ language. It is an important technique that has enhanced the power of extensibility of C++. So whatever the power of extensibility, or whatever the increment of C++, whatever the power of C++, that will be increased by the C++ technique. So it is an important technique that has enhanced the power of extensibility of C++. We have stated that more than once that C++ tries to make the user-defined data type behave in the such way as the built-in data type. So more than one C++ program, like class, taking the class example, so that behaves like a normal built-in data type rather than the user-defined data type. So C++ variables or permits to use various variable or two variables of user-defined types with the same syntax that is applied. That means C++ have the ability to provide the operators with the special meaning for a data type. For example, if I'm using the operator plus, the plus can also be applied to the numbers. The plus, that is addition, can also be applied to the string, that is the characters. So that means the same operator is used for the addition of the numbers. In the same way, the same operator is used for the addition of the strings, that is known as a concatenation. This mechanism of giving some special meanings to an operator is known as operator overloading. That means a mechanism that is used to give special meaning to an operator, that is known as operator overloading. And this provides a flexible option for the creation of a new definition for most of the C++ programs. We almost create a new language of your own by the creative use of functions and operator overloading techniques. That is, it is one of the striking important feature that is available in C++ that is used, that is the operator overloading, as well as the function overloading. That is, we can give or we can overload the C++ operators, that is give the additional meaning to the operators, exception that, or what are the various exceptions by which we cannot overload the operators. So what are the various operators? First is class member access operator. So one of the member operator is class member access operator that is not be accessible. For example, dot star, that is a string. Then the next operator that cannot be overloaded is scope resolution operator. So this operator also cannot be overloaded, that is a scope resolution operator. In the same way, the next operator that cannot be overloaded is size of operator, that is a size operator. Then conditional operator. So these are the four operators that is available in C++ for which we cannot overload. That is, we cannot overload these operators. Else every operator we can overload. That is, we can use the various operator at various places, but we cannot overload. We cannot use the same operator with different argument list. But we can use any operator except these four operators. What are the four operators that cannot be overloaded? One is the class member access operator, then scope resolution operator, then size of operator, and then conditional operator. The excluded operators are very few when compared to large number of operators. As I said, that there are so many operators that is used, like addition, subtraction, less than, equals to, greater than, equals to, greater than. There are so many operators that can be overloaded, but these are the only four that cannot be overloaded in the C++. Although the semantic of an operator can be extended, we cannot change its syntax. The grammatical rules that govern its usage, such as the number of operands, precedence, and the associativity. For example, the multiplication operator will enjoy high precedence than the additional operator. That is, there are multiple precedence that is available for the operators. For example, if I'm talking about a multiplication operator that have a high value, high priority as compared to the additional operator or the addition operator. Remember, when an operator is overloaded, its original meaning is not lost. For example, the operator plus, which has been overloaded to add two vectors, can still be used to add two integers. That is, we can use the add to overload or to add the two vectors. In the same way, we can use the addition, that is the plus sign, to add the two integers. That is, the two integers can also be added, two vectors can also be added using the plus operator or the plus sign, that is the addition operator. Next is how to define the operator overloading, that is how to use the operator overloading. So this is the syntax that is given, that is how to overload the operators, how to do the operator overloading. So to define an additional task to an operator, we must specify what it means in relation to the class to which the operator is applied. This is done with the help of a special function that is known as operator function. So to define an additional task to an operator, we must specify what it means in relation to the class to which the operator is applied. That is done, or this is done, used with the help of a special function that is known as the operator function, which describes the task. The general form of an operator function is, so what is the general form that is given for the operator overloading? This is the general form. First of all, there is a return type, then there is a class name, then there is a scope resolution operator, then operator, that is a keyword that is given, then OP, argument list. So first of all, there is a return type, then there is a class name, then there is a scope resolution operator, then operator, then OP, then argument list. And there is a function body that is covered under the or inside the parenthesis, that is the function body. Where return type is the type of value that is returned by the specified operation. That is, what is the return type? That is returned by the specified operation. And OP is the operator being overloaded. That is, OP is the operator that is overloaded. For example, plus, minus, divide, multiply. The OP is preceded by the keyword operator. So it is preceded by the keyword that is known as the operator. And OP is the operator, OP is the name, function name. So this is the function name, that is the operator OP. Then operator function must be either member functions, that is non-static, or friend functions. So operator functions can either be a member functions or the friend functions, any function that is used. A basic difference between them, that is what is the difference between the non-static members or the member functions and the friend functions. The main difference between them is that a friend function will have only one argument, that is, there is only one argument for unary operators and two for the binary operators, while a member function has no argument for unary operators and only one for the binary operators. This is because the object used to invoke the member functions is passed implicitly and therefore is available for the member function. That is, the friend function will have only one argument. That is, when we use the friend function, there is one argument that is used for the unary operators and only two arguments that is used for the binary operators in case of friend function. While in case of member functions, that has no argument for the unary operators and only one argument for the binary operators, right? This is because the object used to invoke the member function is passed implicitly and therefore is available for the member function. This is not the case with the friend function. That is not available with the friend function, that is only available with the normal member function. Arguments may be passed either by value or by reference. So there are two ways by which we can pass the argument, that is maybe by the usage of value, that is maybe by the usage of reference. Operator functions are declared in the class using prototypes as follows. So how it is used, how it is defined, how it is overloaded. This is vector, that is the keyword that is used, then operator plus vector, that is the vector addition, then vector operator minus, that is a unary minus. Then there is a friend function, that is a vector addition, that is a friend vector operator plus vector vector. Then operator minus vector, that is a unary minus. In the same way, there is a subtraction comparison operator that is used. So vector is a data type of class and may represent both the magnitude and the direction, right? So now, what are the various procedure or what are the various steps or what is the procedure that is used to overload the used to overload the function? That is what is the procedure that is used. So first of all, create a class that defines a data type. So first of all, create the class that defines a data type that is to be used in the overloading operation. Right. Then it declares the operation or operator function OP in the public part of the class. So first of all, create a class and then define the data type that is used in the overloading operation. Then declare the operation function OP in the public part of the class. Then it may be either a member function or a friend function. So when we declare operator OP that can be used either as a friend function or either as a member function. Then define the operator function to implement the required operations. That is, define the various operator, that is the operator function that is used to implement the required operation, that is used to denote what are the various operator that is used to operate various operations. Then overloaded operator function can be invoked by the expression such as. So what are the various ways by which the operator can be invoked, or overloaded operator can be invoked, such as OP X or OP X OP. Anyway, for unary operators, X OP Y for binary operators, OPX for XOP will be interpreted as a operator OPX for friend function. Similarly, the expressions X OPY would be interpreted as this one, that is X dot operator OPY. Right. Now, how to overload the unary operators? So this is how to overload the binary operators. Now, how to overload the unary operators? Let us consider the unary minus operator. A minus operator means, first of all, unary means single values. That is, that takes only just one operand. So that is a unary. So when we use the minus operator, that is used as a unary. So this says a minus operator when used as a unary takes just only one operand. We know that this operator changes the sign of an operand when applied to a basic data item. We will see here how to overload this operator so that it can be applied to an object in the same way when it is applied to an int or float variable. That is how to overload the object when it is applied to an object in the same way as it is applied to an int or float variable. The unary minus when applied to an object changes the sign of each of its data items. That is, whenever we use the unary operator, that can be used for changing the size, that can be used for the binary operations. This is the example that shows the overloaded by unary minus. So first of all, there is a hash include IOStream. So that is the first header file that is used. Then using namespace std. Then class space. So class space means the name of the class is space. And there are three data member that is used, that is X, Y, Z. And there is a public part, that is a member function that is used. One is the get data, one is the display, one is the operator, that is the overloaded minus operator, that is the operator minus. So this is OP means sign of the operator, that is a minus, and there is a blank parenthesis, that means there is no definition of this one because it is declared over here. This is only the declaration part of the member function, not the definition. Then there is a curly braces, closing curly braces, and there is a semicolon. So this is closing curly braces and there is a semicolon. So there is a class space and there are three member functions X, Y, Z, and there is a public member, that is a get data, display, and the operator, that is a operator, that is a minus operator. Then there is a curly braces closed, then there is a semicolon. Right. So next is the declaration or definition of the different member functions. So first of all, there is a return type, that is a void. Then there is a class name, that is a space. So space is the name of the class. Then there is a scope resolution operator. Then there is a get data, and there are three arguments that is used, that is A, B, and C. Right, and there is a closing opening curly braces, and then X is or A is assigned to the X, B is assigned to the Y, and C is assigned to the Z. That is X equals to A, Y equals to B, and Z equals to C. So this is the definition of the get data operator. That is taking the values from the user, that is x, y and the z. So whatever value that is given in ABC, that is given to the x, y, z. Then another one is void space display void. Again there is a return type, there is a class name, there is a display function that is used, and there is a void. Then cout x, y, z. Both the values are displayed in different lines, that is a cout with the help of cout, that is a x, y, z. Then void space, then operator, then there is a minus operator, and there is a blank parenthesis, that is operator, that is a minus operator, that is a unary minus. Then assign the value, or take the negative sign of each value. For example, whatever the value of x that is given as a minus x simply assigns a value or denotes the value as a minus, that is a, if 5 is given as a into the x, then the minus 5. If 10 is given, then minus 10. If the 20 is given, then the minus 20. That is x, y, z. That is minus 5, minus 10, minus 20. Then there is a closing curly braces. Then there is a int main that is used. Then there is a space s. That is s is the name of the object. Then s dot get data. That is get data is used. Or from here, this is the declaration part. From here directly the definition goes to this one, that is a get data. Now what is the value of a, b and c? That is a 10, minus 20 and the 30. So x is assigned as a 10, y is assigned as a minus 20 and the z is assigned as a 30. Right. Then cout s, whatever the s, that is cout, that is used to display by using the function, that is a display function. Now from this the display function will call, that is cout, that is giving the values of x, y and z. Then activates the operator function. Now it's a usage of the minus x, that is operator function is minus s, that is stored in the s. So overload or activate the operator, that is minus x, minus y, minus z. Now cout s dot display. Whenever we use the s dot display, then simply whatever the values of x, y, z, that is displayed in the negative form. If it is negative, it becomes positive, right? Then there is a return 0. So this is one of the important part, that is operator overloading is using the same s as a for the normal data, that is the get data, the same as we use for the operator overloading. Then there is a cout s. So this line as it is printed, then s dot display for displaying the values of x, y, z. Then there is a return 0, then there is a closing curly braces. Now what is the output? First of all, suppose user has given as a 10, minus 20 and the 30. Suppose not, it is mandatory that the user has given 3 values, that is a 10, minus 20 and the 30. So the output what is produced, the 10 is converted into minus 10, minus 10, 20 is converted into 20, because vice versa, because minus and minus are plus. Then 30 is converted into minus 30. The function op minus, that is the operator minus, takes no argument. So there are no argument that is given over here. Then what does this operator function do? It simply changes the sign of the data members of the object s. So whatever the object that is given by the s, it only changes the sign of the data member that is given in the x object. Since this function is a member function of the same class, it can directly access the members of the object which activate. So since it is a member function that is available in the same class, it can directly be accessed, or it can use, or it can directly access the data member that is available in the class. So this is the node that is given. Remember that a statement, that is s2 equals to minus s1. So whatever the values of minus s1 that is assigned, or that is given, or that is stored in the s2, that will not work, because the function operator does not return any value. It can work because the function is modified, or if the function is modified to return an object. It is possible to overload a unary minus operator using a friend function. So it is also possible to overload the unary operator using the friend function. So there is a friend, that is a keyword, then there is a void operator space ampersand s. So there is a void, that is a return type, then there is a operator, that is a keyword that is used, and the operator is minus, so this is minus, then there is a space, and then there is a ampersand s. Right, so space is also a name of the class, and ampersand s is the address of the s. Then void operator minus space s ampersand s. So whatever the operator that is used, that is given in a minus. Then s dot x, that is assigning the or accessing the values of x by the use of the s, that is x dot s equals to minus x dot x. Then s dot y equals to minus s dot y. Then s dot z equals to minus s dot z. So that is assigning the three values, or that is giving the or negating the values by using the minus sign. Note that the argument is passed by the reference. That is, in this the argument is passed by the reference, that is a space ampersand s. It will not work if we pass the argument by value, because only a copy of the object that activated the cell is passed to the operator minus. Therefore, any changes made inside the operator will not reflect in the called object. Why? Because we are passing the reference, so it will not work, or it will work whenever we, or it will not work whenever we pass the value. That is, whenever we pass the content by the value, so it will not work, because this is just that is just a photocopy of the object. So any changes that is made inside the operator function, that will not reflected in the called object. Then overloading binary operators. So first topic is overloaded unary operator. Now next is overloading binary operator. So we have just seen how to overload a unary operator. The same mechanism can be used to overload a binary operator. That is, the same mechanism is the same method can be used to overload a binary operator. In chapter 6 we illustrated that how to add the two complex number. We have seen in the last chapter, that is how to add the two complex number using a friend function. So a statement like c equals to sum a comma b, that is assigning the values, or adding the values of a and b, that is used by the sum function, and assigns the value or store the output in the c, that is used in the last statement. The functional notation can be replaced by a natural looking expression. C equals to a plus b, that is a arithmetic notation. So functional notation means equals to sum a comma b. Then next is arithmetic notation, that is the a plus b. That is done by overloading the plus operator using an operator function. Now the same example, that is how to overload the binary operation, that is a plus operator. Right. So this is hash include iostream, then using namespace std, then there is a class complex. There are two values that is given, one is the real part, one is the imaginary part, right? That is the x and the y. Then there is a public, then complex, that is a complex function that is given. Then there is a complex real and the imaginary. So there are two constructor that is used. How do I know this is a constructor? Because the name of the function is used as compared, or as is available of the class name. This is class complex, and the complex is also used, that is a constructor, because constructor has the same name as the class name. So complex, that is the constructor 1, then complex float real, float imaginary. So there are two parts, one is the real part, one is the imaginary part. Then there are two values that is given, that is x is real is assigned to the x, and the imaginary is assigned to the y. Then complex operator plus complex, that is complex is the return type, then operator means the keyword, then plus is the operator that is used, then there is a complex, that is also a return type, or that is a argument that is used. Then void display void, that is also a return type, display is the name of the function, and the argument is void. Then there is a closing curly braces, and there is a semicolon. Right. This is a complex, and there are two data members, that is x and the y, and these are the two constructors. that is used, and this is operator overloading, and this is the display function, right? Then complex, that is the return type, that is the name of the class. Then operator plus complex C, that is the operator means the keyword, and the plus is the OP or the operator that is used. Then there is a complex C. Then there is a opening curly braces, then complex temp, that is a temporary variable that is used. Then accessing the values by using the dot operator, that is the temp dot x equals to x plus c dot y. Then temp dot y equals to y plus c dot y. Then return temp. So these are the temporary or the float value that is returned by the return argument. Then void complex display function, that is used to display the value. Now there is a int main, that is invoking the constructors, invoking the argument, invoking the return type, invoking the various members like C1, C2, C3. So there are three members, C1, C2 and C3. Then C1 equals to complex 2.5, 3.5. So there are two values that is given. One is 2.5 and one is 3.5. Then next is C2 equals to complex 1.6 and the 2.7. Again two values are given, that is 1.6 and 2.7. Then adding the values of C1 and the C2, that is stored in the C3, that is C3 equals to C1 and C2. Then C out, C1 equals to, that is C1 dot display. So display function is used to give the values, or the display function is used to display the values of the complex number that is in the form of the real and the imaginary. So this is the display function, that is C out, first of all x value, then there is a plus operator, then j value, then y, that is a j will be stored like this one, right? So then calling the first C1 dot display. So this is C1 dot display that is used, that is given the values like this one, that is a 2.5 and the 3.5, then 1.6 and the 2.7, then 4.1 and the 6.2. How is that possible? This is the addition of these two, this is the addition of these two, that is 3.5 plus 2.7 is 6.2. Now let us look at the function operator plus and see how the operator overloading is implemented, that is how to use this operator overloading. So this is the return type, that is complex, and the class name, that is a complex. Then operator, that plus operator, then there is an argument. What is the argument that is given? That is of complex C. Then a complex temp, that is a new variable is assigned, that is a temp. Then temp dot x equals to x plus c dot x. That is with the use of dot operator it can be accessible, that temp dot x equals to x plus c dot x. Then temp dot y equals to y plus c dot y. Then return the temp value, or return the temp values. Then there is a closing curly braces of the operator plus. We should note that the following feature of these function. What is the function of these features? That is returning the values. The one of the feature is it receives only one complex type argument explicitly. So it receives only one type argument, that is x plus c dot x. Then it returns a complex type value, that it returns a complex type value. It's a member function of the class, because everything is on the class, so it's a member function of the class, right? So the function is expected to add two complex number and return a complex value as a result, but receives only one value as an argument. Where does the other value come from? Let us look at the statement that invokes this function, that is C3 equals to C1 plus C2. That also invokes the plus operator, that is used, that is assigned the values, that is given the values with the help of the binary operators. Now the function is, we know that the member function can be invoked only by an object of the same class, as we have studied in the last class or in the first chapter, that whenever we want to access the member function, that can be accessed only by the object of the same class or the friend class of the another class, right? So this can be invoked by the object of the same class. Here the object C1 takes the responsibility of invoking the function, and C2 plays the role of an argument that is passed to a function. So C1 takes the responsibility, that is how to invoke the functions, and C2 is used how to pass the function. So one is used for the declaration, one is used for the definition. So above invocation statement is equivalent to C3 equals to C1 dot operator plus C2, that is usual function calling structure. Therefore in operator plus function the data members of Ci, that is a C1, are accessible directly. So whenever we use this one, so the C1 of member function, that is C1, are accessed directly, and the data members of C2, that is passed as an argument, this is passed as an argument, are accessed using the dot operator. So C1 can be used as a normal function, and the C2 can be used as a, or can be used with the help of a dot operator. Therefore both the objects are available for the function. Therefore every object is available for the function. For example, in the statement temp.x equals to x.c.x, that is getting the value of x and using the dot operator, that is equals to the x plus c dot x. Then c dot x refers to the object c2 and x refers to the object c1. So this is the c1 and this is refers to the c2, because using the dot operator it can be accessible, so it can refers to the object c2. Then temp.x is the real part of the temp that has been created specially to hold the result of the addition of C1 and C2. The function returns a complex temp to be assigned to C3. Figure 7.5 shows that how this can be implemented or how this can be used. As a rule, in overloading of binary operators, the left-hand operand is used to invoke the operator function. That the overloading operators is used to invoke the member function, and the right hand operator is passed as an argument. So this is passed as an argument, that is C2, and this is used directly, that is a C1, right? Now complex operator plus complex, this is the temp variable that is used. Then c dot x, c dot y, that is used. Then temp dot x and the temp dot y, that is also used. Then these are the temp value, that is 4.10 and the 6.20. This is the return value, that is returns the value, and this is given as a c dot x and the c dot y. Then C1, C2, that is a plus operator that is assigned to the C3, that is C3 equals to C1 plus C2, and it is assigns a value, that is some value of the x and y to the C3, some values of x and y to the C1, some values of x and y to the C2. That is the implementation of the overloaded operator, that is the plus operator. Then we can avoid the creation of the temp object by replacing the entire body or entire function body by the following statement, that is a return complex x plus c dot x and the y plus c dot y. What does it mean? That is, we use a class name with an argument list. When the compiler comes across a statement like this, it takes an appropriate number or the appropriate constructor, initializes an object, and then follows the object that is used, that follows the object that is used to make the variable that is used as a binary operators, right? Then such an object is known as a temporary object and goes out of the subject as the content are assigned to other objects. Using temporary object can make the code shorter, more efficient and better to read, right? So next is overloading binary operators with the using the friends, but I'm not going to start right now because I need, let's take a break and then move to the next part. That is, the next part means the practical part first of all, because that is the main part to use the practical functions, right? So let's stop over here only the theory part. Let's take a break right now, then move to the next part, that is a practical part, that is the class concepts, right? So let's stop over here only. Let's take a break, then move to the practical part. So come back from the break, let's start the session again. So now let's move to the practical part, that is practical approach of C. Where is tab of C? This is tab of C. In the last class we have discussed some basic example of class, right? Now I'm going to continue with the same class concept but with the new example, that is a nesting example, that is how to use the class and how to use the different members, right? So first of all, use the header file, that is hash include iostream.h, then class set, that is the name of the class is set, then there is a curly braces, that is a curly braces that is given, then there are two argument that is used, that is m and the n. So these are the two data members that is used. Then there is a public, that is a publicly it is assigned, that is a public part. Then again there are two or three data members that is used, that is a void input, that is a void input, then there is a void, right? Then there is a void display, and then there is a void. This is not void, this is void. Then uses the int, that is the largest, then there is the void. So these are the three functions that is defined in the public part. So these are known as the member functions, and m and n are known as the data members. So there are two data members and there are three member functions in a class. Now the class will be closed by using a curly braces. This is the curly brace that is used, and there is a semicolon that is used, right? Then there is a int. Now definition of the member function that is used, that is a return type, this is the class name, this is a scope resolution operator, this is the largest, right? Then there is a void that is used. Now then again there is a curly braces that is started over here. Then checking the condition, if m is greater than equals to n, then check the condition, that is return m, then there is a else part, then there is a return, then there is a n, this is also return, that is also a closing braces. Then uses void set, then there is a scope resolution operator, then there is a input, then there is a void. Then again there is a curly braces that is used, then cout, then input, write down input values of m and n. It is given in the next line, so this is slash n, right? Then cin, then m, then cin, this is m and n, right? Then there is a closing of this one, right? Then there is a void, then there is a set, then there is a scope resolution operator, then there is a display, then there is a void. Then again there is a curly braces that is given, right? Then simply uses the cout, that is for printing part, that is the largest value equals to then again if there is a largest value, and again there is a function that is used, that is the largest, and again this is used in a next line. If I want to use, this is also used in a next line. This is also closed over here, and this is also closed over here. Like this one, we have to use, right. Then there is again the closing curly braces. Then there is a int main that is used. That is int main. Then there is a set. Then there is a. Then a dot input. So this is the object that is used. So that is a dot input. Simply inputting the value. Then I'm not using capital letters. I'm using only small letters. For example, a. Then a. Then a dot display. Right. Then there is a return 0. Then there is a closing curly braces. Then again there is a get ch. Now if I compile the code, there is only one error, that is unreachable code, that is the get ch. Why there is an unreachable code? Because we have not used the header file, that is hash include conio.h, that is mandatory for get ch. Now if I compile the code, there are two warnings, that is unreachable code, that is the get ch. Okay, yeah, one more thing, the return 0 must be used at the end. Now that is pasted over here. Right, now if I again compile, there is a no error, though no warning. If I execute, now enter the input the values of m and n. Suppose I enter as a 10 and the 20. The largest value is 20. Now suppose I give the value as a 1 and the 2. The largest value is 2. Now everything is going in the one screen. So first of all, clearing the screen. Now if I compile the code, now inputting the value of this one, again this one, that is clear screen is not working over here because this is the class. Yes, this is the class that is used, so this is not used over here. Right, so we have to use over here, that is a clearing the screen. So there is a int main, then this is CLR FCR. Now if I compile the code, now the screen will be clear. 1256. Now again if I compile, the screen will be clear. 2 1, largest value is 1. So this is the program that shows how one member function is included in the or nested in the another member function. So let's start with the starting. So first of all, two header files are defined. That is two header files are defined, that is the m and the n. So there are two header files that is used, that is the m and the n header files, sorry, iostream and the conio.h, and there is a class that is used, that is a class set. Then there are two member functions, two data member that is used, that is the m and the n. Close. Class name is set, and there are two member data members, that is the m and the n. Right. Then uses the public part, that is the input, or uses the public. So first of all, there is an input, then there is a display. So first function is your input function or the member function, and the second one is the display, and third one is the largest function, that is the int largest. So first of all, there are two return types. In the first one, that is a void. In the second one, there is another return type, that is a int part, right? then the class will be closed by using the curly braces, and then there is a semicolon. So the class set is contains two data members, that is the m and the n, that is the private part, and three member function, that is the public part, that is input, display, and the largest, right? Then define the various member functions like int set, so that is a return type, that is a set, then there is a set, then there is a largest. So this is the class name, right? This is the class name, that is a set, this is the return type, that is the int, this is the function name, that is the largest, this is the argument list, that is a void. Then check the condition. If m is greater than equals to n, then return the m. So if the m value, that is the first value that is given by the user, is greater than the second value, then simply returns the first value. And if the second value is the largest one, that is if m, that is the first value, is smaller than the second value, that is the second value is largest, so return the n values. That is, if m is greater than equals to n, then return m, else return the n, right? Then void input, void set input void. So this is the input function that is defined over here, that is the input function. Then cout, input the values of m and n. Now getting the values of m and n from the user, that is cout m and n, that is cout m and n, or values of m and n. Then cin m and n. So getting the values of m and n from here. Then cin m and n, that is getting the values of m and n from here. Then close the curly braces. Then void set display. So this is the input function that is used, that is getting the values of m and n from the user and store in the given in the or store in the memory by using the cin, like we does in the case of the scanf, right? Then void set display, this is the display function that is used, there is a void. Then cout largest value. Now this is one of the important part, this largest function that is defined over here. Now this will be used over here. So whenever we use this function, so first of all it takes the input, right? Then it takes the display, but in the display there is a largest function that is used, or that is from here the cursor will go to this one, that is the largest function, and the return, that is the m and the n, will be returned based on the object that is used, right? Now next is int main, that is the main function. Then set a, that is defining the object of the set or the class set, that is a a. So that is a set a, then clear screen, then a dot input. So whenever there is a data, whenever there is a output that is used, that is a set dot a. So instead a dot input is used, it is directly jump to this one. So whenever a dot input is used, it directly jump to this one, and inputting the value, taking the value from the user, that is the input the values of m and n. Then scanning into the memory. Then next is a dot display, the display function will be called, that is this one, this will called, and there is a largest function in between the display function, then the largest function will be called. Then there is a get ch, and there is a return 0. That's why it is first asking for this one and returning the value by using the largest function that is displayed over here. That is, the largest function have a role, but the object that is used, that calls the display function, because the display function contains the largest function. This is known as nesting of member function, that is, one member function is used inside the another member function. So this is the program that shows the nesting of member function, that is how one member function is defined within the another member function, right? So this program is clear to Larry and Joseph, both of you? Larry and Joseph, this program is clear to both of you? Okay, you are Joseph. Okay, all right. Now let's move to the next program. Nesting. Okay, Larry. Now, taking the member function or taking the values as a, or take the static member function that is initialized to 0 at one glance. For example, or we may also use the friend function over here. That is how to use the friend function, right? So this is the program that shows the friend function, that is hash include iostream.h, then hash include conio.h, right? Then there is a class that is a sample, right? Then there is a int a, then int b, so that will also be declared in a one line, that is int a and the b, right? Then there is a public, then there is a void, that is a void value is given, then there is a set value, then it is showing or it takes no argument, then it will display in the same class, that is it is an inline function, that is a is given as a value as a 25 and b is given a value as a 40, right? Then there is a closing curly braces after semicolon, this is the closing curly braces, then there is a friend function that is used, that is also defined in that is a friend, then there is a float, then there is a mean, then simple s, that is a friend function, and then the class will be closed, that is the class part is over, then there is a semicolon, then simply defines the function, that is a friend function, because one function we already defined in the class only, that is becomes the inline function, that is a float mean, that is a simple s, the program should contain the proper indentation also, so there should be a proper indentation, that is a float mean, then there is a return type, that is a return, then float, then getting the value of s dot a plus s dot b, then that is divided by 2.0, then there is a semicolon, then there is a return type, then there is a int main, then there is a sample x, then x dot set value, that is used, right? Then cout, then simply uses the mean value equals to, then double quotes, then there is a value, that is a mean, then there is a x, then again, then there is a slash n, that is a cout, then there is a return 0, then there is a closing curly braces, right? Then here only, then there is a get ch, and there is a clear screen over here only. Now if I compile this code, there is no warning, there is no error. If I execute this code, the mean value is 32.5. Why mean value is 32.5? Let's discuss. So this is a program that shows how the simple friend function that is within the same class, how the friend function is used. That is not in the two classes, that is within the single class only, how the friend function will be used. So first of all, it is used, or it is defined, two header files, that is the iostream.h and the conio.h. So these are the two header files that is used. One is the iostream, one is the conio.h, right? Then there is a class that is a sample. So class sample, then int ab, that is the two variables are defined, that is the a and the b, right? Then there is a public part, so this a and b are the data members of the class sample, right? Then there are two then there is a public section, that is the member function definition. So that is a void set value. The set value is the name of the function that is used, and there is a return type, that is a void, that is void set value. Then it is assigning the values, it is giving the values as a 25 and the 40, that is the a contains 25 and the b contains 40, that is a set value function. Then there is a friend, float, mean, sample, s, that is a friend function is used, and then there is a float, that is a return type, float, and the function name is mean, that is the name of the function is mean, and the return type is float, and then there is a sample s, that is a argument list that contains a sample s. Then there is a closing curly braces, and then there is a semicolon that is used, that is friend, float, mean, that is sample s. So these are the two data members. That is a private by default because nothing is given. If I am storing this in the public part, then that is a public part. If I am not storing in anywhere, that means this is a private part. That is a and b are the data member, that is a private by default, right? And then there is a public declaration. There is a void set value that is given, that is assigns the value of a as a 25 and the b as a 40. Then there is a friend, float, mean, sample s, that is a friend function or the friend keyword is used. Then there is a float, that is a return type. There is a function name, that is a mean, and there is a sample s, that is a argument list. Then the class will be closed, right? Then there is a float, mean, sample s. This is the definition of the friend function, that is a mean. So there is a float, mean, sample s. Then return float s dot a plus s dot b, then divided by 20. So for accessing the member functions, for accessing the data values, it is using the dot operator, that is s dot a, that is access the value of a as a 25, then s dot b, that is access the value of 40, that is the 25 plus 40, that is the 65, that is divided by 2, that is 32.5, that is a 65 is divided by 2, that is given as a 32.5. Then there is a closing curly braces. Then there is a int main. Then object can be defined, that is a sample x, that is the object. Then there is a clear screen. Then x dot set value, that is the x is the name of the object, and the dot operator is used to access the value, access the set value function. This is s dot or x dot set value. So set value is the function that is used, that is given as a value or assigned as a value as a 25 and the 40. So now the a has a 25 value and the b has a 40, that is a x dot set value. Then cout mean value equals to mean function. So whenever this is used, that is a cout mean value equals to, so directly it will jump to the mean function, directly it will jump to the this function that is given over here. This is the definition. So whenever there is a mean value, that directly jump to this one, then calculates the value and returns the output. Then there is a get ch for showing the output. So first of all, getting the values, that is a set value, that is assigning the values of a and b, then getting the mean of the set value that is given by the user, that is a set value. Right. So if I define or if I call this function, if I use this function as a member function, so if I change the value as a 2020, for example, this is 20, this is also 20. Now if I compile That is a success. If I execute, the mean value is 20. Why? Because 20 plus 20 is 40. 40 is divided by 2. That gives the value as a 20. It is given in a float. Maybe it is a point form, decimal form, maybe it's an integer form. Any form it is given. So it takes the value according to the mean value. Right. So now if I compile this code, that is the mean value is 20. Now if I again execute this code, the mean value is 20 again. If I change this one, now if I compile, the mean value is 25, because 30 plus 20 is 50. 50 is divided by 2, that is a 25. So mean means, for example, in this the mean means of the average, that is addition of the two numbers and then divided by the 2. That is 30 plus 20 is 50. 50 when divided by 2, it gives a value as a 25. So this is the friend function that is used as a sample class, that is used in the sample class. So I saved this function with the help of the f2 as the name, that is a friend function. Now this program is clear to each and everyone? Hello, yeah, this program is clear. Larry, Joseph. Okay. Okay, good. So can anyone explain me what is a friend function? So can anyone explain me what is a friend function? Hello, can anyone explain me what is a friend function? Hello.